Hello everyone, in this video we're going to go over the exam 2 review and we're going to go in part 2 on the problems. So the first problem, we have a kite that is released at an average rate of 4 feet per second, and we want to know how high is the kite given that the string is pulled out for 18 seconds. So this means that we have a situation where we have the kite over here, like our kite is here, and we have this angle of inclination of 70 degrees. So we can kind of make a triangle here. This is not a very good line, but we can make a triangle. Okay, something much better here. And so once that we have this triangle, then we can obtain information of how the height is going to be. We want to know pretty much this h, and we have information on this hypotenuse because once that we release, this hypotenuse is going to be 4.5 times 18 seconds. And notice that this is 4.5 feet per second, and then we're multiplying by 18 seconds in the air. So this is gonna give me at the end 4.5 times 18, and seconds cancels with seconds, so this is gonna be feet. And of course that is 81, and so we know that this here is gonna be 81. So we're gonna call this D, and D will be 81. Now, since we want to obtain the height, we have the opposite to the angle, so we can use the sine of the angle. So we know that the sine of 70 is equals to opposite, which is h, of our hypotenuse, which is 81. So pretty much we can say, well, here our height is going to be 81 sine of 70 degrees. And that is going to be 76.1 feet. Okay, so simple enough. Now, number 2 is a very similar situation. We have a surveyor that stands 40 feet away from a tree, and it measures an angle of inclination to the top of 73. So we have a situation like this again, and we have this 73 degrees, and we have again, can go on a straight line. Okay. What is this? Is this erasing this? So more or less this is a triangle that we have. Now the same thing, we want to know, we have certain information. We have that this is 40 on the ground, and we want to know what this h is. So we can relate some of the information to obtain what we have. Since I want to know h, which is the opposite, but I don't have the hypotenuse, then I can probably go by tangent. Before, you didn't have the value of tangent, which is sine over cosine. So let's just assume that we have the information of sine over cosine, which is tangent. So h is the tangent, h over 40, sorry, is the tangent of 73 degrees. And so this means at the end, h is just going to be 40 tangent 73, which is going to be 130 0.8 feet. So notice that it's important to remember the trigonometric function definition. And here we use the opposite over the adjacent. So now let's move to some equations. For the equations, it's going to be fundamental that you remember that you have the unit circle. And so let's just draw a circle here. Let's just have a circle. And let's just recall and have some axes. Let me just have this here. Okay, and so given any point that we have here over the unit circle, let's say the point xy, this is going to be to a certain angle from the horizontal, so we have this angle theta here. So any point is making a particular angle with this x-axis. Okay, so that produces the consequence that any point xy can be seen as the cosine of the angle, comma, the sine of the angle. And so in other words, I can say, well, x is cosine of theta, y is sine of theta. And so this gives me different information for what I'm going for. So for example here, if I have 25 cosine of x is equals 13, and I'm thinking that x is an angle between 0 and 2 pi, so pretty much in the circle. So instead I'm going to be changing my thinking, and it's not going to be theta anymore, but it's going to be x. But I'm gonna think of this as theta, so it's easier. So I can say, well, so cosine of theta gotta be 13 over 25. Okay, but if we're thinking about what this means, it means that in the unit circle, we're talking about a positive value for x. Since remember, this is the cosine, so it means that we're talking about a value of x, and that value of x, it gotta be positive. So where x is positive, x is positive here, and x is negative here. So it gotta be an angle that is in the first quadrant, and it's in the fourth quadrant, because I get this point, and I get this point. Those 2 points are good for 13 over 25. They're both going to be giving me an angle that works that way. So if I just use my calculator and get what this is going to be, so I'm going to get theta is cosine to the minus 1 of 13 over 25. And when I get this in my calculator, I'm going to obtain that this is 1.024 radians. And this is going to be in quadrant 1. Okay, so this is going to be my angle in quadrant 1. How do I know this? Well, this result is in radians. And remember, the radians go from 0 to 2 pi. So what is pi? Pi is 3.1415 radians. So that means that over here, between 0 and pi, we're going from 0 to 3.1415 something. And if I go to 2 pi, then I'm going to 6.20 something like that. So of course, if I get 1.024, that's clearly an angle that is here on the first quadrant. Now to obtain the value on the first quadrant, so my second answer, so theta 2 is just going to be what? It's just going to be the entire 2 pi, but I'm going to subtract the angle that I just got. And so that's going to be 5.259. Okay, and this is also radians. Notice that you got to remember that to obtain, this is like my reference angle, the first angle that I obtained with the calculator. It might be often an angle that is in the first or the second quadrant, so I gotta be careful what type of angle is. And I'm obtaining this angle right here, and so that angle is gonna work to let me obtain the other one. So for example, here I have this one, and if I want the one that is in the fourth quadrant at the same height, which will be this one, the thing that you need to do is consider is this whole turnaround minus this little piece. But this little piece is equivalent to theta. It's the same thing. So that's why I can do 2 pi minus theta. And that's why I get this one. Now, if the angle is on the second or the third quadrant, the situation is different. And we're going to see that on the next equation. So for B, we have that 9.5 sine of x minus 3.6 is 4.8. So the first thing is that you need to isolate sine of x. So 9.5 sine of x is equals to 4.8 plus 3.6. And then sine of x is going to be what? The sum of this, which is going to be 8.4. And so now we're going to divide by 9.5. So 8.4 divided 9.5. And so that's going to be what we get the sign here. Let me use theta again. So now theta is sine to the minus 1 of 8.4 over 9.5. And this is going to be now 1.085. And again, this is in radians. But now notice that this is a sine. So when we're talking about sine, we're talking about y coordinates. So if I'm talking about obtaining the sine value is now the y. So instead of getting this pieces here, and so let me erase a little bit. So instead of getting this ones, when I'm getting this sine, I'm getting this height. So because it's positive, the sine is positive, so the y is positive, and I'm getting first this angle, which is on the first quadrant, and that's the first theta that I obtained here. And the second angle is going to be this one here, this one that is made by this point, and that is of course given by this entire angle. So that's theta 2. But if you think about it, notice that this theta is just this here as well. So theta 2 is just going to be pi minus theta. So I'm finding my second angle here by subtracting from pi the first one. And so that's going to give me, this is 3.14 something. So if I subtract 1.085, I'm going to get 2.057. And that again is in radians. So notice that it all depends on the positioning of the angle. Now, last, we have this equation that's going to give me cosine of theta, and let's move this minus 7 plus 2, and this is 6. So 6 cosine of theta is minus 5, or cosine of theta is minus 5 over 6. Now this is a negative value. So because we're dealing with a negative, so let me make my picture here again and put the quadrants. Okay. So now we're dealing with a negative, and it's cosine, so it's an x. So a negative cosine is something over here. Establishing a very good line. So let's say it's a value over here in the negatives. So now my first angle is here. It's going to be this one here, and it's going to be given by this. So this is my theta angle. So when I do theta equals cosine to the minus 1 of minus 5 over 6, I'm actually getting this big value. Okay, and so that's going to be 2.556. It would be good if I can get the reference angle. And to get the reference angle, or so this is angle number 1, and then the angle number 2 is this one here. So one thing that I can do is I can get this value here, alpha, which is the reference angle, right? And add that to pi, and that's going to give me one of the values. Okay, or the other thing that I can do is simply find out what happens if I take just the entire 2 pi and subtract this value here. But let me do that actually on the initial way that I propose. So I have this value here, theta, and so I want to find the reference angle that I have here. So I want to find out what this one is, alpha. So for that, we're going to say alpha is pi minus theta. So we do this pi minus theta, and that's going to give me 0.58, 85, 59, 26, 53, 59. So this is a long thing, but now to get my second angle, theta 2, then it's going to be actually pi plus this difference. Okay, so pi plus alpha. And so adding this to this angle here, we got 3.727. And that's a pretty good approximation. Notice that we can actually, if you get this, we can actually get this from doing instead 2 pi minus the original angle theta. That's another way of getting to the same point. So everything here where we're going, it depends of the positioning of the angle. Now let's check some values with the function sine inverse. In this question number 5, we have that the function y equals sine to the minus 1 of x is graph, and we have several points plot. We want to find the missing coordinates. So one of the things is that the most easy to find out are the ones where the x is missing, since we have a value in terms of 1 minus 0.5, or something in the mid of those particular values, and we should be able to get some from just checking here the particular value. So if we get a, we have minus pi over 2. You got to remember that pi is 3.14. So if you divide pi by 2, you're going to get like 1.5 or a little bit more than 1.5. And so you can see here that this corresponds to this. And then this point A is going to correspond in x to minus 1. So there's a lot of ways of following what the result should be. For minus, for d, which is pi over 4, remember pi over 4 should be this point over here, right, d. And so you can be able to just check what that particular value is just by remember that sine and cosine are the same. And that's going to be a little bit more than 0.5, so it's 0.7 something. So that's going to reflect a square root of 2 over 2. And one way of obtaining this value is notice that this is y. So if y is equals sine to the minus 1 of x, that means that pi over 4 is sine to the minus 1 of x, or that sine of pi over 4 is x. And so if you remember, that's going to be a square root of 2 over 2, or that's what you get if you use the calculator, and so you can find that value. Now, in the values that you're getting, the coordinate x is a little bit more easy to just find out what that value is, because you can go ahead and directly use the value x in the function sine to the minus 1 and obtain that. So for example, here you do sine to the minus 1 of minus the square root of 3 over 2. When plugging the square root of 3 over minus the square root of 3 over 2 here, it's going to provide it with a y that is going to be minus pi over 3. In C, you have minus 0.5, and so this is going to be minus pi over 6. And then in E, when you plug sine to the minus 1 of 1, then you're going to have pi half. So there are multiple ways that you can approach this questions. But for the most part, you should support yourself on the fact that you have the function there to produce some values. Now, question number 6 says, what is the value of theta in degrees in the right triangle that we have over here? This question is just recalling what information you can get with the opposite and the hypotenuse of a given angle. And so, of course, if you remember, that's probably going to be the sine of theta. And sine of theta is the opposite over hypotenuse. So sine of theta is 4 over 9. So theta is going to be sine to the minus 1 of 4 over 9. And that's going to give me 26.4. Okay. Now, in the next question, we have that a lighthouse is positioned 1 mile off the shoreline, and the beacon of light it shines turned at a constant rate. R is representing the distance from the beacon to the point where the beam meets the shore, and we give two values of theta in degrees, for which we have the R of 1.6 miles. So over here, we want to obtain those particular two values of theta that correspond to the equation that we're obtaining. So remember this, we can create a triangle here with this opposite, or that also is going to reflect this angle here. So we might be thinking in this triangle, or we might be thinking in this triangle. Regardless of that, we're going to have that the sine of theta is going to be 1 over 1.6 miles, since this is the opposite value, right, over the hypotenuse, and we have that we have this rate is 1.6 miles from this here, and we have that this distance is 1 mile from the shoreline. So we have this 1 and we have this 1.6. So we can set up sine of theta being 1 over 1.6. Now if we do then theta is sine to the minus 1 of 1 over 1.6, then we're gonna get that this is 38.7 degrees. And once that we have this is an angle that is the first reference value. Remember, we have sine of theta equals particular positive value. Then in the unit circle, that means that we're having values here on the top. So that means that I'm going to have one angle here on the first quadrant, which is what I got here, and a second angle here on the second quadrant. So for the second angle, I just need to do 180 minus 38.7 degrees. And I just gotta be careful here because I obtained this in degrees, because the values that are being requested is in degrees. So you just gotta be careful with your calculator not to be using radians when you should be using degrees. Now, question 8, we have that in a forest, population of wild coyotes is oscillating in a size over a 2-year period according to this model. So this model is a sinusoidal function, and we have a bunch of things that we can obtain from here. So the population starts from 2015 and is going to reach a critically high level when there's about 450 coyotes. The supply food at that point begins to diminish, and over the next 5 years, and the population of coyotes is going to be a critical level at some point. So we want to find out when that's going to be. Okay. So the first thing is that having this 1.1 t minus 1 it can be difficult to manage. So the first thing that we can do is we can call that just theta. So theta is 1.1 t minus 1. And so with that, our function becomes 145 sine of theta plus 356. Okay? And we want to know when this is going to be 450, because that's the number of coyotes. So this is an equation that we can manage more easy. And if we find out and solve for the sine of theta, we have 450 minus 356. That's going to be 94. And then divided by 145. So again, we have here a positive sign. So again, in the unit circle, this means that we're getting two angles, one on the first quadrant, one on the second quadrant. So using theta equals sine to the minus 1 of 94 over 145, that's going to give us around 0.71. And so that's going to be our first theta. So I'm going to call this theta 1. And theta 2, of course, because it's here in the second quadrant, is going to be just pi minus, that's 0.71, which is going to be let me check how much that's going to be. Calculator. So pi minus 0.71 is around 2.431. Yep. I miss my okay. So this is going to be 2.431. Now I can get then my different values. Remember that this is theta 1 and theta 2. So I gotta remember that those depends on uncertainty. So I can say 1.1 t1 minus 1 is gonna be equals to 0.71, and my second equation is gonna be 1.1 t2 minus 1, and it's gonna be equals to 2.431. And so once that I solve for these equations, I'm gonna find that this is approximately 1.65, and this is approximately 3.21. There are two ways that you can do this, and it's solving the equation as normally by algebra, or you can use it on your calculator and use solver to get the values of t. Okay, so the coyote population then is going to be definitely a risk for the interval between 1.65 to the 3.21 years. And that will be the answer for this question. Now, last question number 9. We want to find all the values for which 1.7 sine of 2x plus 2.14 is equals to 3.24. But now we have a reduced interval here. So we're only going to be using the interval 0 to pi half. Okay. All right. So first and then we can solve for sine of 2x. And so if we solve for sine of 2x, this is going to be sine of 2x is approximately 3.24 minus 2.14, which is going to be 1.1. And then divide by 1.7. So this is equals to this. And so I have that 2x is sine to the minus 1 of 1.1 over 1.7. Same thing as usual. I'm going to have two values here that are going to have this is an area. So I'm going to have 2x1 is equals sine to the minus 1 of 1.1 over 1.7. The first value that I obtain is 0.704. And this is in radians, of course. And the second angle, or the x2, is going to be, of course, pi minus that 0.0704. Remember, here we have a positive value of sine, so this is giving me on the unit circle two values, one in the first quadrant, one in the second quadrant. And so now that we have this, then we can find out what x1 is. So this first one is going to be 0.352, and x2 is going to be 1.219. Once that we find pi minus 0.704 divided by 2.